No. I used the wrong camera. Shoot. Okay, there's that. Howdy, y'all. Getting things going. Back. One side. All right. There's that. Oops. Okay. All right. I think. All right. Getting the banners on the website updated, and we're ready to go right at 9. Excellent. Howdy, y'all. I'm Ryan, the calculus tutor. This is the Tuesday night stream. Uh, I'm here up late because I know a lot of you are up late working on your math. So I'm here to make sure you have somebody to ask your questions while you're up late doing your math. Let's see what we got. Okay, queue is open. No questions currently. With that said, I'm going to go ahead and here, we'll get rid of this. Oops, that's not what I wanted to do. Oh, I guess right at the top of the stream, right here at the beginning, I think this is what I'm just going to start them all with. Abolish ICE, completely and totally. Very simple. Happy to talk more about that, but for right now, we're doing some math. So I do have a problem here that we could look at. This is not. This is a problem I worked on with a student that I work with one-on-one. It's the night stream. I'm gonna be yawning. Yeah, I offer one-on-one tutoring. You can see my website, thecalculustutor.com, for more. I guess just as a little intro. Yeah, it says submit your math questions at thecalculustutor.com. You know what I should do? I should change this to say live. That's actually the URL, and I think that might make things a little bit more clear. So let me adjust that in all of my pre-set up little. I already have this little message on all of my and all the days for this coming week. There we go. So yeah, really quick, I guess let's talk about that. How do you question? How do you submit your question? How do you get your math questions answered? Let me switch over my screen share. Boom, boom. All right, thecalculustutor.com/live. Right here. So if you go to that URL, that's what you'll see. If you just go to thecalculustutor.com, oops, wrong button. Right, that's just my home page. You can still get there though. You can either click the banner at the top, or there's a submit a question button here in this box. But yeah, I would just say go to calculustutor.com/live. And then you can see there is a submit math questions button under the main menu. So you can click that. Or you could scroll down a little bit to the submit math questions section. There's another link to the submit questions form, which I recommend you use. You can also just email your questions directly to me, ryan@thecalculustutor.com. If we go to the form, let's show you there. It should load up this Google form. It might pop up a sign-in screen first. You have to be signed into a Google account to use this form. If you try to use your school Google account and it still won't let you, that's just because your school has stuff outside of your school network blocked. So just email me your question. Again, ryan@thecalculustutor.com. Everything that I asked for on this form would be a good idea to include in your email though as well. So I'm going to go through this form really quick. And yeah, that'd be the same stuff to include in your email. A checkbox to say, yes, I know my email address is being recorded. You have to be signed in and it records your email address because you can submit files, and that's just a Google requirement. That's not. But I take advantage of the fact that I'm going to get your email address one way or the other by emailing you back the links to my answer and the notes here, and that enables us to do this process completely asynchronously. If you want to. But anyway, very first box, who are you? Just how would you like me to refer to you when I'm answering your question? This question was submitted by such and such. Tell me who such and such is. Tell them. So it's whatever name you'd prefer. You could also include your pronouns here if you like. Um, and then where did this question come from? I mostly mean what class. I assume most of the math questions I'm going to get are going to be from people in math classes. So just tell me the teacher in the class, right? Uh, Mix Anderson's geostats, Miss Smith's calculus. Simple as that. If it's not from a class, just give me a little bit about where it's from. Um, it's not that big of a deal. Then what is your question? So you don't need to retype the math problem here because at the bottom you can submit pictures, and my idea is you'll take pictures of the problem. So what I expect here is for you to just tell me more specifically what is it I can help you with about the problem. If your question might just be, can you show me how to do this? That's totally fine. But you might also be something like, uh, the problems the problems we did in class didn't have fractions. So can you show me how to deal with the fractions in this problem? Or the equations we graphed in class didn't look like this. Can you show me how to graph the equations when they look like this? Just things like that. You might also tell me, because if you send when you send the pictures, if you send a picture of your entire like textbook page uh, or worksheet page, or you send me a whole PDF packet or whatever, this would be a good place for you to tell me which problem or set of problems you want me to work on, right? So, uh, you know, you might tell me number 12 or something like that. But yeah, this is just a place for you to be a little bit more specific than it's basically a place for you to communicate to me about how I can help you. We're gonna skip this little box really quick, but then we'll go down here to the attach images. So my idea is take a picture of your entire wherever the problem is, right? If it's in a textbook or on a worksheet, take a picture of the whole page. If it's online, take a screenshot, um, and then you can just attach them here. Um, Make sure your picture includes diagrams or charts or whatever, even if they're blank and you're supposed to fill them out, still include them. And I'll use them in my notes so that my notes look like what you're supposed to turn in. Another useful thing to send to me, though, would be a picture of any work you've done related to the problem. If you started the problem but got stuck or got the wrong answer, still send me that work. If you did you're asking me about 12 and you did 11 and they're like the same type of problem, send me a picture of your work for 11. Um, it or send me notes, or like if you guys went over problems like that in class and you have one or two of those problems of your work, or just your notes from class, the most related thing you can send me of your own work, um, related to the problem, can help me sort of get the context of in class what's being expected of you and things like that, right? It just gives me a little bit more information and helps give me a little bit more insight into where you're at with the problem. It's not required for you to send me a picture of your work. If you do, I promise, it is my promise that it will not show up on stream. I'm not here to show, I know people that would make people anxious. I totally get it. Uh, you know, I'm not asking you to broadcast, your math work to the internet. Uh, that picture you send to me of whatever work you've already done, that's just for me to give me a little bit more insight into how I can best help you, how best to answer your question, and how best to help you build some confidence around whatever you're asking about. So that's what this box is about. So my promise is that I won't share your work on stream. Then why am I asking permission to share it? You don't check that box. That box is there because for when I start getting college and university students using this service. Um, at higher levels of math, the actual most helpful thing can often be just like when you have somebody proofread an essay for you, it can be really useful for somebody to go through your problem because at higher levels of math, the problems can be really, really long and have a lot of steps and have just a lot of different processes involved. And so at that level, a really useful thing can be to have somebody go line by line. And at that point, the type of, the students that are in a place where they're looking for that sort of help, they likely would no longer have the sort of anxiety about having their math broadcast on the internet. Um, so yeah, best of both worlds. Don't worry about that checkbox. I promise I won't share your work on stream. Um, it's there for the people who need me to go through their work on stream. That's the thing they most need from me, but I don't anticipate that's most people at this point. So yeah, that's the process here. Oops, wrong button. No, was into the stream. So we'll do that. We'll go back to the notes. When I work on a problem, I do it in these notes here. This is the Miro board. And this is where I work through problems, and I can link to specific places on this in these notes. So when I answer your question at the end, after I'm all done with the stream, and once the stream is processed, I will send you a link to the specific timestamp in the VOD recording of the stream and the specific place in these notes where I answered your question. I'll send you both of those links. I'll email them back to you. And so you're able to get your questions answered even if you can't watch the stream live. And then you're perfectly free to email me back follow-up questions or clarifying questions, things like that. If you ever can catch the streams live though, absolutely feel free to pop into chat, say hi, and you can ask clarifying and follow-up questions in chat and get real-time answers. So yeah, that's this process. I'm gonna go ahead and this is a problem that I worked on with a student that I'm really glad that I had an opportunity to work on this problem with that student because this is a type of problem that is kind of a classic math word problem that I think is a good one because you can't just take the numbers out of the problem and put them into a particular, like, this number goes here, this number goes here every single time, and all the word problems are exactly the same. The nouns are just different or something, right? No, this is a problem you actually have to sort of think about, and there is a problem solving process to it. So yeah, let's look at this, shall we? So we have a chemist. Of a chemist's potion boils over and leaves a huge pool of potion in the laboratory. He knows that if he asks his apprentice to clean it up, it would take 20 minutes longer than if he did it himself. So he decides to have the apprentice help him do the job. Together, they clean the mess in 30 minutes. How long would it have taken if the chemist did the job alone? So this is a classic like working together type of problem. Other versions of this problem have like multiple people painting houses, right? So they're like Joe and Suri are painting houses. Joe can paint one house in 4 days. Suri can paint one house in 3 days. How long would it take them to paint one house together? Right, that's a pretty classic, house painting problems are a super common version of this. I like that this is at least a little bit different and a little bit more, um, interesting, if only barely so. So what's going on here? We don't know how long the chemist, this brewer of potions, we don't know how long it would take him to do it alone. In fact, that's what we're trying to find. That's our goal, right? We don't know how long the apprentice would take, but we do know it would take 20 minutes longer for the apprentice. Um, and that's it. That's really all of the information we have. Oh, nope, it's not. We have one more piece of information. I'm sorry. Together, 30 minutes. Right. When they join their efforts. So yeah, how it doesn't seem like we have that much information, honestly. Here's what makes problems like this tricky is they don't really phrase anything in using words that kind of clue you into what you're maybe supposed to think about. The ideas are there, but it was a little bit more clear when I talked about like painting the houses right. Suri can paint a house in 3 days, right there, a house in 3 days. That's a rate, right? A rate is just some unit divided by another unit. Typically, time is the unit when we're talking about rates. So miles per hour, that's a rate. Um, Gallons per minute. Again, that's a rate. That's gallons per divided by minutes. And that's the key to problems like this is you want to focus on the rates. So that's what we want to do is we want to look at the rate at which they work. So what's our rate here? Our rate units is mess per minutes. How much of a mess can they clean up in 1 minute, or how many minutes to clean up a single mess, right? Same idea, or mess per minute. So let's look at so we're going to call our chemists rate. We're going to call that C. Simple as that. We'll just call it C. And we don't know what it is, and that's what we're looking for. So I've made it green here. That's our goal. Okay, but we also have the apprentice, right? So the apprentice rate. Oh, that is, I'm sorry. Let's make this really clear. I just wrote C, but I want to make that more clear. So we'll come back to the apprentice rate in just a second. It is, the apprentice's rate is 1 mess per C minutes. There we go. Okay. So that's the key here, right? We don't know how many minutes or how much of a mess in a single minute, but we do know they're cleaning up one mess, and there's an estimation about that. So one mess in C minutes, right? When you have a rate, you have two spots where you could potentially have a variable, have an unknown. You have is the amount of whatever is happening in that time unknown, or is the amount of minutes unknown, or the amount of time rather. In our case, it's minutes. And we knew it was minutes because all they use minutes in the problem. I guess it didn't specify. All right, so let's talk about the apprentice. We don't need to give the apprentice a different variable because we know the apprentice, according to the chemist, can clean up one mess in C plus, oops. There we go. C plus 20 minutes. What? So we have our rates, but I guess I didn't specify. Why do we want to focus on rates? Rates are the things in a problem like this that you can actually add together, right? For example, the Joe and Suri painting houses. If Joe can paint a house, a single house, what I say, 4 days, that means he paints a quarter of a house per in a single day. Suri, on the other hand, can paint a house, what I say, 3 days. So she paints 1/3 of a house per day. So if they work together, each day, Joe's going to paint a quarter of that house, and Suri is going to paint 1/3 of the house. So they'll have a quarter plus 1/3 painted, and then we can figure out, if there's a little bit left over, it doesn't go in perfectly. That's totally fine. That's what we'll do the math or do the division or whatever, and we'll get a number. But yeah, rates add together really nicely. If they are the same units, and this is mess per minute, right? If they have the same units, you can add them together. And that's true for pretty much all rates. If the rates are the same, then if you want to combine those two things, you should just be able, the two things with a rate, you should be able to add them together. You do it with like miles per hour too. If you have, this is a little bit weird to think about, but if you had, let's have an aircraft carrier because it's really big, right? So you have an aircraft carrier moving through the water at 20 miles per hour, right? And then you have a jet taking off from the aircraft carrier, and the jet is moving at, say, 60 miles per hour on relative, right? That's what the speed, relative to the aircraft carrier is. But the total speed of the jet is 60 plus 20, would be that 80. Anyway, if rates are the same, you can add them together. And if they're applying to the same thing, adding them together tells you the combined rate. So that's all we're trying to do here. What's really great is we know how much time total this should take. So what we're going to do, so now we can just add the rates together. So their combined rate is 1 over C plus 1 over C plus 20. So that's their combined rate. And notice our only unknown in there is the chemist's actual rate. And so if we could find out that C, we'd have our answer to the whole problem. Okay, but this isn't an equation yet. It doesn't have an equal sign. But we do know something about the total amount of time it takes. But here's the thing. How do you turn a rate, that's what I'm trying to say, into something that's not a rate, like miles per hour? How do you turn it into just miles? Well, what does a rate do? It tells you how much of something happens in a certain amount of time. So if you know how much time, then you know how much happened, right? So like 20 miles per hour for 20 miles per hour for 3 hours. Well, the first hour is 20, then another 20 is 40, then another hour is 20, so 60. 20 times 3. So you can you multiply. So if we do, so just over here as a little aside, if we do a mess per minutes, and if we multiply that by minutes, an amount of time, the minutes will cancel out and we'll just be left with how much of a mess was cleaned up. But we know how much of a mess is going to be cleaned up, one whole mess. So here's what we're going to do. We're now going to multiply combined rate by work time. So now we're going to take, so we know they worked for 30 minutes. The problem tells us that. So it's one mess over C minutes plus 1 over C plus 20 minutes. This is also a mess. And now we can distribute this 30 right there. Well, actually, that's not what we're going to do. We're not actually going to distribute it. And it's going to equal one mess at the end. So these minutes right here will cancel out with both of those minutes. Those units will cancel. But what we're actually going to do is we will divide by this 30 here and divide over here. Is that confusing to do it that way? There's multiple ways to do this. We could multiply it in. It might even actually make sense to go back up here and combine these together first. And then this is a single value. I think, yeah. So pardon me. All of this stuff is still true. But we're gonna do something first. We're gonna actually combine these together. How do we do it? We got to do common denominators. So we need them to have the same denominator. This one has a C, but remember, you can't just add stuff to the parts of a fraction. You can only multiply or divide because the fraction itself is division. So you can only use multiplication or division. So this fraction, we're going to multiply top and bottom by C plus 20. Boop. C plus 20 right there. This fraction, we're going to multiply top and bottom by C, like that. And so what we end up with is we end up with this one right here, C plus 20 over C times C plus 20 plus C over C times C plus 20, like that. Boom. We can combine like terms here. These have the same denominator, so we can add their numerators together, and we get 2C plus 20 all over C times C plus 20, like that. C's in parentheses are make this look maybe a little confusing, and I apologize for that. I don't know if it's helpful if I make all my C's green. Does that help? differentiate it. Boom. There we go. I think that helps. Yeah, that helps differentiate a little bit. Keep my coloring consistent. Okay, so we now have so this is their combined rate, and it looks complicated, right? Um, and it is. It's complicated in structure, but we understand fundamentally what it is. It's their combined rate. Just like when we added Joe and Cerise, I combined their names together into Josie. Um, Joe and Cerise house painting rates together. We've combined these together. We just have an unknown in there. And with the structure of it, it makes it a little bit complicated. But that's totally okay. So we have a single rate now. And so what we want to do is take that rate. And so we can still think of this as how much of a mess they can clean up and in how many minutes it takes them to clean up that much of a mess. It's still mess per minutes. So what we can do is we can take our known of 30 minutes. Oh, that might be really small, y'all. Sorry, I forget that as it gets filtered through the screen share and all of that, and you all might be watching on a phone. So let's write it better, a little bigger. 30 minutes. And that'll be times this value here. There we go. And that will equal how much they cleaned up. They cleaned up one mess. So we need to get rid of those minutes, but this is really awesome. If we multiply these in, the minutes there just cancel with the minutes in the bottom. Units are like variables or constants, right? Like if you have a unit in the numerator and a unit in the denominator, they cancel each other out. This is the same thing, miles per hour, 20 miles per hour for 3 hours, 20 times 3, you cancel out, you just get the miles, right? Same idea. And then, of course, we need to multiply this in. We need to go whoop and whoop right there. And so we will do 30 times 2 is 60 C plus 30 times 20 is 600. And that's all over C times C plus 20. And it just equals 1. The mess is the only unit there, equals 1 mess. And now check out what we've got. We have an equation with a single variable in it. Now that variable appears in 3 different places, so we might have to deal with that. But for now, we have an equation, right? This is really great. Yeah. So from here, we've dealt with the word problem, and we've completely converted the word problem into just a math equation. And now we know if we can solve this for C, we already know what that C represents. We put it in here in such a way that it represents the answer we want, the amount of time it takes the chemist. It would take the chemist alone to clean up the mess. So we just need to solve for the C. Well, what can we do here? We have a fraction. Let's multiply both sides by that denominator. It'll cancel out there, and over here we get 1 times that. Well, 1 times anything is just itself. So we have 60C plus 600 is equal to C times C plus 20. Now, you might notice there's not going to be any way to just get the c by itself with the way this is structured because of this multiplication. So what we're going to do is we're actually going to multiply that in. And so this side will stay the same for right now. And then this side will become c squared plus 20c. And we have a quadratic. Whenever you're dealing with a quadratic, you just want to get everything on the same side. So we will minus 60c minus 600 to cancel those out, minus 60c minus 600. And so we end up with 0 equals c squared, 20c minus 60c, so minus 40c, and then minus 600. And this whole problem ends up boiling down to a quadratic. There's a whole bunch of ways to solve this quadratic, right? The 3 typical ways to solve a quadratic are factor it, factor / complete the square. Like, I regard those as more or less the same method. Quadratic formula or graph it. The quadratic formula always works, but it is computationally intensive. It's that whole messy formula, and you have to be very careful as you're doing your calculations. Does this factor? $15, $40. You know what? I know what the answer is to this. I just realized it doesn't factor. It never hurts to check if something factors. So we could graph it, or we could use a quadratic formula. May as well practice using quadratic formula, right? So let's remind ourselves, what is our quadratic formula? I like the quadratic formula because it always works. Factoring doesn't always work. I guess technically completing the square always works. Ooh, actually, I kind of wanted to talk about completing the square. You know what? That's what I'll do. In the next session, I wanted to talk about completing the square, and I can go back to this problem to right here and use this problem as an example. So for our purposes, we'll do quadratic formula. So the way quadratic formula works is if you have 0 equals ax squared plus bx plus c. So you have a quadratic equal to 0, which we do have. You want to just look at the coefficients, the numbers in front of the variables, and then the constant term. So if you have an equation that's in this structure, then the variable, the solution to that equation, the value of the variable is always negative b, so the negative of the middle coefficient, plus or minus, we actually get 2 solutions. Again, that middle coefficient now squared, minus 4 times the first coefficient times the constant term, all over 2 times the first coefficient. That's our quadratic formula. It is, if you do a bunch of practice, you don't have to memorize it. So I didn't put any work into memorizing this. I've just used it so many times over the years that I know it. So with that in mind, we should be able to figure out that our C is equal to negative, oops, negative, negative 40. So B is negative 40, C is negative 600. Ooh, actually, that's always a thing you can do, right? That can be a useful thing, is identify your A, B, and your C. A is equal to 1. There's nothing in front of the C squared, so it's implied to be 1. B is negative 40, and C is negative 600. Honestly, that's always a good idea when you're doing quadratic formula. Just spell out what your A, B, and C are. And remember, they're just numbers. They don't, the x's don't, or the variable doesn't come with them. It's just the coefficients. Okay, so negative B, so negative negative 40, plus or minus the square root of negative 40 squared minus 4 times 1 times negative 600 all over 2 times 1. Okay, so we can just keep working this down. Negative negative 40, that's just positive 40, plus or minus square root. 40 squared, or negative 40 squared, is positive 1600, minus, or negative times the negative is positive, so plus 4 times 600 is 2400, or 2400, all divided by 2. So we get 40 plus or minus the square root of, this is going to give us 4,000 all over 2. There we go. Nice. So the square root of 4,000, we want an actual number here. So we'll reduce this down to a decimal. So yeah, root 4,000 is roughly 63.2425 if we round it 2 decimal places, roughly that. So this is, so we actually get, we have this plus or this minus, right? So this splits into 40 minus 63.25 over 2 and 40 plus 63.25 over 2. Whenever you use a quadratic formula, and honestly, whenever you solve a quadratic, all quadratic equations mathematically have 2 solutions. Sometimes that solution like matches up, like you get 2 and 2, or let's do a better example, like 7.5 and 7.5, right? It's still technically 2 solutions. We just say that that solution that occurs twice has multiplicity. That's a different topic for a different day. Anytime, any polynomial will always have a number of solutions that equals its power. So since a quadratic has a power of 2, it has 2 solutions. A cubic, which would have a power of 3, would have 3 solutions, and they always do. Sometimes the solutions double up though. But that's kind of interesting, right? We discovered there's sort of a quadratic at the heart of this problem, and quadratics have 2 solutions. So does it take the chemist 2 different amounts of time to clean up this problem, or to clean up the mess? Well, if we do these out, 40 minus 63, that's negative 23.25 over 2, which is roughly negative 11.63. This would be minutes, because it's an amount of time, and we know it's in minutes. Negative time, though, this one, on the other hand, this would be 103.25 over 2, so that's going to be 51.63 minutes. Okay, 51 minutes makes much more sense. At least it's a positive number. What does negative time mean? So this right here, this is what we call an extraneous solution. It emerges because we used a quadratic to answer this question, right? But this question is a real question in which negative time doesn't make any sense. So even though this solution emerged mathematically, algebraically, it's not relevant to the actual problem, to what the physical reality that this quadratic represents for us, right? We sort of worked this problem down into this quadratic at the core of it. And this quadratic absolutely does. Negative 11.63, if we plugged it in to this equation, it would absolutely solve this equation. It is a solution to the quadratic. It doesn't apply to the specific circumstance. Because remember, math is just a tool we use to problem solve and make sense of the world and make predictions and all that sort of stuff, right? Um, but just like any tool, it doesn't understand the context in which it's being used. A hammer doesn't understand, like, you know, a hammer will smash your thumb just as easily as it smashes a nail, right? Uh, the hammer doesn't understand the difference. It's up to you to understand the difference. Same thing here. So this is what we refer to as an extraneous solution. It's a totally valid mathematical solution to the quadratic, but it doesn't apply to our context. So our actual answer is this other one, 51.63. So it would take the chemist about 52 minutes to clean the mess alone. Boom. I do encourage you, when you're dealing with word problems, as your very, very last step, write your answer as a complete sentence. It doesn't have to be a long sentence. It doesn't have to be an elegant sentence. Just as a complete sentence. Rephrase it in terms of the question that was being asked. The question that we were being asked originally was, how long would it have taken if the chemist did the job alone? So our answer should be, it would take the chemist blank to do the job alone. And we just fill in the blank. It would take the chemist. You should actually be able to write the sentence frame for your answer before you do any math work at all, right? You shouldn't, because you're just answering the question in a complete sentence. The reason I encourage you to do that is it builds the problem solving sort of habits and pathways in your brain and stuff like that, and it helps you connect what you just did back to the original problem. And notice we're several steps away from the original problem, right? um and while your goal might be to just get the math done, somewhere in there is another goal to actually learn the math and understand and learn these skills. And this is how you do it, by in just a few places putting in that little tiny bit of extra effort, like rephrasing your answer as a complete sentence. um and I remember back in high school, I hated doing stuff like that too. It wasn't until college that I started to see the value of it. So you don't have to believe me that it's worthwhile. Well, you don't have to believe me that it's worthwhile, but I will continue to reiterate that it is worthwhile. It is a small little step that uh can have pretty meaningful results for you. Um and there we go. That is this process. Um yeah, I'm wondering if this would be easier if we just flipped these over, but I don't think so. 2c plus 20. Yeah. Yeah. Sorry, I was thinking it through a potential streamline for this, but I don't think it would actually work. Um, so there we go. That is one of these sort of tricky little rates problems. So I think what I'd like to do, yeah, I think next time I want to talk about completing the process called completing the square. And actually it would be relevant to this problem, which is great. Um, and in fact, I think my we would still get the exact same solutions, but it wouldn't require all of this quadratic formula nonsense. Which I mean, the quadratic formula, once you've practiced it a few times, several times, um, it's it's just kind of tedious, and you just have to be careful that you're getting your calculations correct. So you just if you're doing calculations in a calculator, you have to know how to use the calculator and things like that. That actually might be um, a good streaming topic. Is I guess I would need to put together. Um, yeah, maybe I'll start thinking about sort of calculator tips and tricks and best practices and all that sort of stuff. Um, and things you always have to keep in mind when you're using a calculator. Huh. Yeah, I don't think I think that's one I'd want to like prep ahead of time, or at least be accumulating things over time. Because I think in the moment there's all sorts of stuff that would be useful to talk about, but wouldn't occur to me in the moment. That said, I could also add like I could just do it could just be a small mini segment within this where I just am like, in today's calculator tip, and then at some point I could just compile all of those together into like a single thing where I go through all of them and have them all collected together. That could be useful. All right. Well, I think that was interesting. If you have math questions, you should submit them to thecalculustutor.com/live. And I'll go through them on stream. I'll answer your question. I'll generate some notes. But then after the stream, I will email you links to the place in the stream recorded VOD and the place in the notes where my response is, and you can just access them literally anytime. Eventually, I will delete this notes file, but that's like I won't delete it until after the school year's over, right? Um, so yeah, you will those links will just always work. Same thing with the VODs. That will stay live for like a long time. So you could access it really whenever and then access it again later on. So access it to finish the assignment that you needed to finish and then access it, a little bit later to help you study for the test or whatever. So next stream is tomorrow at 3:30. That's our afternoon stream. And that's, I guess, when I'll go over the completing the square stuff. That'll be great. Ugh. I'm very yawny. I do apologize. But it's pretty much always going to happen with this late stream. Oops. There we go. Just getting the website back updated for tomorrow's stream. Oh, yeah. So yeah, next stream tomorrow at 3:30 p.m. PST, though. I'm on the West Coast. It sounds like South Eugene and I think Monroe middle school students staged a walkout today, or it must have been today because they didn't have school yesterday. Today in protest of ICE. The high schoolers marched down to the federal building. I do believe students from Springfield High School, I think, also staged a walkout. I don't know if they got down to the federal building here in Eugene. That'd be a long way for them to go. But like really, really awesome, y'all. Just so amazing. I'm grateful, and I respect it, and I'm in awe. You guys are doing the work, and it's the right thing. You're doing the right thing, and so I just got to say I appreciate it, and I'm proud of you. Keep going. All right. Well, I think that's what we got here today. I will check for submissions one more time. But I haven't seen any people in here, so I assume there aren't any. All right. Well, good stuff, y'all. I'll see you tomorrow at 3:30 p.m. Have a good rest of your night. Get good rest.